Multivariate analysis. Looking at one variable is useful, but it's not enough because nothing in the real world exists in isolation. Age doesn't exist on its own. Income doesn't exist on its own. Health doesn't exist on its own. Everything is connected. And the moment you start looking at those connections, that's where data becomes meaningful. That's what multivariate analysis is. It's not complicated. It simply means looking at multiple variables at the same time, understanding how they interact, how they influence each other, how they move together. And this is where things start to change. Because now you're not just observing data, you're uncovering relationships. Let's slow this down. In univariate analysis, you ask, what does this variable look like? In multivariate analysis, you ask, what happens when these variables come together? And that question is everything. Because reality is not one dimensional. Let's take a simple example. Imagine you're analyzing health data. You have age, smoking status, exercise levels, lung function. If you look at age alone, you might see a pattern. If you look at smoking alone, you might see another pattern. But the real insight comes when you combine them. What happens when age increases, smoking increases, and exercise decreases? Now, you start seeing something deeper. You start seeing risk. And risk doesn't exist in one variable, it exists in interaction between variables. That's multivariate thinking. And this is where beginners struggle because it's easy to look at one column. It's, it's harder to look at relationships because relationships require thinking, not just observation. Now let's connect this to AI. Every machine learning model is essentially learning relationships, not individual variables. A model doesn't care about age on its own. It cares about how age interacts with everything else. That's how predictions are made. That's how patterns emerge. That's how intelligence appears. So, if you don't understand multivariate relationships, you don't understand your model. You're just using it. And that's a dangerous place to be. Because when something goes wrong, you won't know why. You will just see the output. And that's not intelligence, that's dependency. Now, let's talk about correlation. This is one of the first things people learn in multivariate analysis. Correlation measures how two variables move together. If one goes up and the other goes up, that's positive correlation. If one goes up and the other goes down, that's negative correlation. Sounds simple, but here's where people make mistakes. Correlation is not just causation. Just because two things move together doesn't mean one causes the other. And this mistake happens everywhere in data science, in media, in everyday thinking. You see two patterns and you assume there's a connection, but reality is more complex. There could be hidden variables, external factors, random coincidence, and if you don't question that, you build false conclusions. Now think about this at scale. AI models are finding correlations constantly, thousands of them, millions of them, but they don't understand those relationships. They don't know what's casual, what's meaningful, what's noise. They just detect patterns. So if your data has misleading relationships, your model will learn that and then reproduce them. That's how bias enters systems, not intentionally, but structurally, through relationships that weren't fully understood. And this is why multivariate analysis matters. It forces you to explore those relationships before the model does. It gives you control. It gives you awareness. It helps you ask, does this relationship make sense? Not just, does this improve accuracy? Because accuracy without understanding is dangerous. Now let's go deeper. Multivariate analysis is not just about pairs of variables. It can involve 3 variables, 5 variables, 10 variables. And the more important variables you add, the more complex the relationships become. This is where humans start to struggle. Because our brains are not designed to handle high dimensional data easily. And that's where AI becomes powerful. It can process complex relationships at scale. But again, processing is not understanding. That's still your role. Now think about visualization. In univariate analysis, you use histogram, box plots, etc. In multivariate analysis, you move into scatter plots, heat maps, pair plots. These are tools to help you see relationships because once you see them, you start thinking differently. You start asking better questions. You start noticing patterns. And that's where insight comes from. Not from the model, from you. Now let's connect this back to your dataset. Multivariate analysis is not just technical, it's a way of thinking. It's about understanding that nothing exists alone. Everything is connected. Every decision you make is influenced by multiple factors. Every outcome you see is a result of interaction. And if you ignore these interactions, you misunderstand reality. And this applies to data, AI, and systems. Single variable thinking is simple, multivariable thinking is real, and most people stay at the simple level because it's easier. But real insight requires complexity. Now, here's the key: you don't need to understand everything, but you need to be aware of everything that is connected. The awareness changes how you think. It makes you slower, but more accurate, more careful, more intentional. And in the world driven by AI, that becomes your edge. Because machines can process relationships, but they don't question them. You do. And that difference is everything. So next time you work with data, don't stop at one variable. Go deeper. Look at how things connect. Look at how they influence each other. Because that's where the truth is. Not in isolation, but in interaction.